Namaskar learners, I welcome you to this teleconferencing session on MGGL 003, that is our lab course on geospatial analysis. It is a third semester core practical course worth 4 credits, and you will be giving the term and examinations for this course probably next day or day after tomorrow. So this program is just an overview of the lab course on geospatial analysis. So in ODL system, 1 credit is equals to 30 student study hours. So this is a 4 credit lab course. So total study hours is 120. So what is geospatial analysis? It is a core skill in modern geography combining concepts of remote sensing, GPS, GIS, cartography, modeling and data analysis. You have studied all these courses like remote sensing, you have studied in the 4th semester, and it is MGG 012, and you have studied the core theory course on geographical information system in the 3rd semester itself. It is MGG 011. So you are very much clear with the concepts and theory part, and in this lab session we are having the hands-on practical session being conducted at your study centers. So just a quick review of all these terminologies, like remote sensing, as the word suggests, it's a remote sensing. So when we sense some object or we detect something with the help of some sensors which are not directly in contact with the object, it is a remote sensing. So in this case, when we study about Earth, we study it through the satellites which are sensing the Earth and sending information in the form of imageries, satellite imageries. So these are raster imageries, and we perform geospatial analysis based on these imageries. Now we have global navigation satellite system, or we also collect information through global positioning system. It is more popularly known as GPS, but we say global navigation satellite system. So it's a constellation of satellites that provides information about positioning, or in simple terms, it gives you the lat long or the coordinate information of the object, whether it is stationary or whether it is moving, and also timing services on a global or regional scale. Now, geographical information system is a sophisticated computer-based tool designed to capture, store, retrieve, manipulate, analyze, manage and present spatial and geographical data. So when we collect information with the help of remote sensing satellites in the form of raster images, and we also add on the data collected through field work in the form of GPS points and tracks, etc., we all feed all the information on a GIS platform, and then we perform analysis on that data, and then we generate the output map on a GIS platform. So GIS has the following key components. It is made up of hardware, software, data, people and methods. Hardware is the workstation or the systems where we work, the desktops, our laptops, etc. Even the mobile phones are now equipped with modern GPS sensors and devices. Although it is accessing the GPS from the AGPS or access GPS. So it is taking GPS information from the third party, not directly capturing the GPS information. So and then we have software. The software is like, in this case, in our open and distance learning system, we mostly use the open source softwares which are easily available to the learners. So in GIS or geospatial analysis, we are using QGIS. So when you go to the Google, you type QGIS and you will be directed to the QGIS website, and then you will download the latest version over there, or you can download the more stable version, because these softwares are getting updated every now and then. In just 2 weeks or 1 month time they are updating. So a new version is coming very frequently, but there is a stable version option also given, so you are suggested to download that stable version. And then when you download that software, you save it on your systems, and then you follow the instructions and install it. After you install it, you can see a number of functions, and we'll just show you at the end of this session. I'll just go through the software in very brief. Then we have data, because we need data to perform geospatial queries and analysis. So we have data, so we can manage data in a way that it is available to the learners or the end users in the form of output map. And the people are those professionals who are trained in GIS softwares or handling GIS. So when you perform your practical exercises in your study centers, they will give you hands-on training on the software, and then you will receive that skill, and then you can perform the analysis in your own way as the output map or whatever is required in your study. Then we have methods. The methods are various tools and techniques with the help of which we conduct these analysis, and with the help of GIS software professionals. Now, what is the course objective? The objective is to facilitate the learners to handle GIS software, to enable the learners to develop spatial data sets, to implement spatial analysis and modeling for decision making, and apply geospatial analysis techniques to the real world projects like natural resource management, disaster management, and other environmental studies. And number of things which you are researching, you are studying, you can put the knowledge acquired through these in your studies. Now, what are the learning outcomes? At the end of this course, or after going through this course, after studying this course, you should be able to handle spatial and attribute data. You should be able to conduct queries, overlays, modeling, generate map layouts and visualizations, and apply GIS in real world case studies, as I told you earlier. Now this course is of, as I told you, 4-credit course, but the lab exercises are of 14 days, and they are split into 2 sessions, and each session is 3 hours, is of 3 hours. So total of 84-hour sessions you will be doing, and after that we give some time to the learners to go through the study material, the booklet, the practical booklet we are providing, that you should go and then perform lab exercises also, maintain your practical record book. So altogether it will come to 120 study hours of the students. So we have 26 lab exercises, and it includes a mini project. This project is not to be confused with the project which we are having in the 4th semester. This is only based on the, I'll show you the format of the exercises. This is like day 1, session 1 and 2, and these are the exercises. Like exercise 1 is dealing with familiarization, then 2 with exploring software, then 3 with data preparation and data generation, then again data generation, then whatever data we have generated, we form integration of data, like as I told you that we collect GPS information, remote sensing data, and whatever we digitize, all the information is collected and integrated in a GIS platform. So that is called data integration. We can also integrate data from the web sources like OpenStreetMaps, Google Earth Engine, Waze, etc. So all these are given in your practical exercise book. And then we have exercise 7, which is data integration and adaptation. Then again we have analysis and query. After the integration of data, we perform combined analysis. Then the 2 exercises are dedicated to your analysis and query. And then we have output generation in the form of output maps. to the end users. Then we have some exercises dealing with the application of GIS and remote sensing, like soil geometry and surface geometry and soil erosion modeling, then land use, land cover mapping, crime analysis, network analysis. And after this we have hydrological analysis, and then also we give a detailed exercise, two exercises dealing with web GIS and information portals. Now, exercise 23 to 24 is related to the mini project which your study center counselor will give you based on the exercises you have already done. And then on the last day, that is day 14, you will have your practical record book submission and viva. And one day the term and examination will also happen. So this way the lab courses are designed. To give a full overview, like days 1 and 3 dealt with data fundamentals, days 4 and 5 dealt with queries and visualization, 6 and 7 with surface and soil analysis, and then 8 to 10 with the applied GIS, then again advanced modeling and web GIS in 11 and 12, and then 13 and 14 with the mini project or whatever your counselor is giving you in the form of practical record book. And then you submit the practical record book and you have your viva on the final day. So teaching is dealing with hands-on teaching, software teaching, use of open source. As I have already told you that we use open source software, and in some study centers some counselors may also have access to the licensed software, so they are also teaching that. But in the study manual we are preferring the open source software which is easily available to the learners. Any learner can install it and study and perform whatever analysis they want to. So we have real world data sets and in the form of remote sensing, GPS, government portals, etc. And we follow a problem solving approach. Evaluation scheme is related to like lab exercises, and viva is of 70% weightage, and the practical exam, the term and exam for practicals will have 30% weightage. So continuous assessment will have more weightage in this case, contrary to the theory in which continuous assessment in the form of assignments etc. you have 30% weightage, and term and examination you have 70% weightage. But in practicals you have just the reverse. The continuous assessment will have the 70% weightage and the term and examination will have 30% weightage. Now after obviously you will gain a degree after the completion of this program, but the skills you have learned through this course will go a long way in your career, and you can get jobs in governmental organizations, various urban planner, hydrologists, resource managers, various research institutions, higher research institutions, and environmental and utility services. Several jobs of GIS analysts and GIS professionals, you can get jobs if you are very much. So active participation is required for success. You keep your practical record books updated. Project, the mini project in this case, which you do with the help of the exercises you have learned, will connect the lab learning to the real world problems. And lastly, I would like to say that geospatial analysis is not just a tool, it is a way to solve geospatial problems. Now I'll give you a brief overview of the software. I have I told you, you go to the Google and you typed QGIS, and then you will be directed to the software and how to install the software. You take the more stable version and you install the software. Here I have just installed the software and I am opening a file. Like this is a IGNOU map of IGNOU. These are the red ones are the line features, and these are the roads, and the pink ones are the buildings, the academic blocks. And then if we scroll through this, then we find the residential blocks in the form of purple buildings. Okay, Now you this just a brief overview of the software. You see this this is the menu toolbar. Like you have project menu, on the menu edit, view, layer, settings, plugins, vector, raster, databases like web, mesh, processing help, etc. Then if you want, you can open a project from here. Project open. If you have saved a project, or if you want to start a new project, you click on this button, project new, and then you will be uh, uh, having a blank empty project, and then you can create your features. And you can also import. Here you have import export options, like you have created some drawing in AutoCAD map, which is also a GIS software. So the files are in the form of DWG or DXF extensions, so those files also can be opened through here. Besides, you can export the layers also, or you can export in the QGIS. We are mostly dealing with the shape files, so you can import or export shape files in the form of DXF, and you can work in other software platforms with the help of this. And now let's come to this layer option. Here we have layer option. I hope it is visible. Layer option, and you, if you want to create a new layer, you say create new layer, then you go to new shape file. Okay, now you, if you want to create a layer, you would write here the file name, then you give the geometry type. If it is a polygon type, like say if I create a layer like this is the layer name, and I give it a geometry like it is a polygon geometry. And then you have to give the coordinate reference system. In this case, in our where our India is situated, this is the best coordinate reference system. So project CRS, or the project coordinate reference system, is EPSG 4326 and WGS 84, which suits this one. And then we name a field. Field are the columns on which we have information. So we name different fields and we add, and then we give the information. Like if we add a field, say ABC, suppose this is the name of the field, and this is a text, whether it is text string. Suppose if we want to add a field like name of the entity, so we are adding the field name, and it is a text string, and we give the length as 80. Then we add to fields. It is coming here as one default field will always come like ID. This is an integer and it will always come by default. Then we add other fields also, like if we want to give one area field, so we write one area here, and then this is area is not text, so we come, it is neither an integer, it can be in decimals, so we give decimal, and then we give the length of that decimal like 10, and say precision 3 we take, and then we add it to the field. So you see, this in this way we can create a shapefile with n number of fields. Now if we start digitizing, then we have to go to this digitizer, toggle editing. Like in I have already one field like academic and administrative blocks of IGNOU, and I am making it active. Once you, this is the layers panel. Okay, learners, this is the layers panel, this is the browser panel. Whatever we have to browse, we can browse through here, and these are the menu toolbars, as I told you. This is the digitizer toolbar. So once we click on this toggle editing, it comes in the toggle editing mode, and this layer is active. So whatever entities we are adding, like this is a polygon layer, so if we click on this polygon and we add a new feature. One more thing, before digitizing, you have to click on this horseshoe type thing is visible. It is the snapping option, and you have to maybe when you install a new software, you will not get these options there. So you have to go to the view panel, and then in under panels you have to add various things like and under toolbars you will get like snapping toolbar, advanced digitizing toolbar, all these various options which are needed for our map work you will get over here. So suppose we have to create in geography, like when we do work, we work on suppose we have a state map and we are digitizing several districts which are interconnected. So let's say this is a polygon and we are digitizing it. So once we have this activated, we click on this and we activate this vertex. So this will the vertex will be visible, like if I come here, you see a pink thing is coming. This is the vertex, and when we click on this, it will snap to that snapping option we have like activated. So it will snap to this point, and then we are like creating another polygon which is interconnected. Now viewers, you see, we don't need to digitize the area which is common, because if we even if we digitize, no matter how much precision we do, we will get some space, so it will not completely fit there. So there is one more option over here, like allow overlap on avoid overlap on the active layer. So we have activated this thing, and then we continue digitizing, and we just come over here and right click. By right click, you will see, just a moment. But now we come to the digitization. It is not, otherwise it will come over here. Just you don't need to draw the entire thing, and you will just see that it will be, you just give an ID, and then you write the name, say XYZ, and then you click OK. You see, you have not digitized this portion, but if you click on this I identify button, you see that it is coming over here. It is, you did not need to digitize over here. So in this way you can digitize the interconnected polygons, and after you digitize, you can just go to the attribute table. You see this layer is still in toggle editing mode. You can save the edits whatever you have done, so that in case the laptop is shut down automatically, you don't lose the data. And in this when you open the attribute table, you see there are so many options over here. You see, you can add a field here, you can delete a field here, you can create a new field, you can organize the columns, you can bring some columns to the rearrange the columns. And then you have a field calculator. Like if you add a field, say I want to create a new field. Suppose the field name is area. We already have a field name as area. So I am writing area 1 2. Okay, now we again put it in decimal, and then length and precision we have selected. The field will be done here. You see, it is area 1 2. Now if I go to the field calculator and I want to update the existing area field, like area 1 2, this was the field we added. If we go to this and if we perform like find the area, we go to the geometry, and then we this option we select, and then we apply and OK. Then you see this area is updated in this. Area is updated in this. Maybe we are having different projections, so there is variation in the previously formed data and the अभी जो calculation हमने किया है, there is some variation. Okay, we can check on where there is error or anything. Besides, you can also check this option. This is a measure tool. If we click on this, like measure area, see, you can just it will measure in square meters. You can just click on this, and you will, whatever area you want to find out, you can just click over here, and that you can just check whether the area calculation you have performed, like it is coming 2711 meter square approximately. So you can check with the table also whether it is coming correct or not. Then you can go to the here we don't have internet connection, otherwise if you want to load OpenStreetMap, you can just click over here XYZ tiles, and you can just click on the OpenStreetMap. It will be opened in your and just you can check whether whatever you have digitized, it is in sequence with the OpenStreetMap or not, or you can change the projection it is if it is not completely matching. So learners, this was a brief overview, and let me see if there is some more time we can take up. Like there are vector and raster geoprocessing tools. You can create buffer, clip, uh, difference, dissolve, intersection. Geometry tools, you can create centroids, check validity, add geometry attributes, etc. Then in raster also you can perform certain analysis, okay, slope, etc. So all the exercises you have dealt with in your practical record book. You can see the practical manual we have provided. We have done all the most of the exercises, and with all the snapshots we have provided, you can just go. You can see in the layer panel we also have georeferencer. If you want to, first thing when you download a satellite imagery, you will have to georeference it. So georeferencer, when you go, you can add GCPs with the help of these point icons. Add GCP, delete GCP. You first have to open the image over here, and then you provide the lat log information on all the four corners, and then you go to the transform settings and give the CRS, and then linear and nearest neighborhood, and then click OK, and then you go to start georeferencing. So in this way you can also georeference, and after georeferencing you can digitize. I have asked you how to digitize interconnected polygons, how to do snapping, how to do set the tolerance and all. So in a way, a brief overview I have given you for this course, and I hope you will do well in your examination. All the best for your term and examination, and in case you have any doubt in future, you can ask me, reach out to me at satyaraj@ignou.ac.in. Thank you.